Okay. All right. Once again, hi Nigar, Elmira, good to see you again. I hope you are all okay. And we have 2 weeks left. So that means that we have 4 hours with you, okay? So Nigar, when is the exam, 26 or 27?
I don't know clearly, but I think 27.
Yeah, I think so, 26 or 27. I heard that actually. Okay, good. As you know, last time we started this paper, and also I think I shared with you, I think it was, I don't remember. Today is April 12th. Okay. Even if you did this or not, it's okay. Let's have a look at the questions quickly. Okay. So we are a bit slow, but let's see what we can do. And if we can cover 2017 and also 18, it would be great. Okay. Today after class, if I don't forget, if I forget, please remind me. I will send you 2 more papers. At least if you have a look at the questions before you come to the class, and at least you have some idea about the questions so that we can go much faster. And last time we solved these questions, I think we did until 14. Okay, so today we will continue from here. Okay, so Nigar, Elmira, usually solving multiple choice questions, that's much easier than other questions, right? After all, you can check your answer is correct or not, especially this kind of question. It says that P represents a whole number, find the value of P if, right? So quickly, one way is you can just substitute, right? Which one works? For example, P equals 5, P equals 7, P equals 9, 11. If none of them works, then actually we just choose the right answer, the last one. So that's one way, because if we try to solve this another way, also we can solve this in another way, but actually that involves quadratic equation that you did not study yet. Okay, so let's do maybe 1-2 questions together. After that, I will ask you to do the questions. So if for example, if P is equal to 5, at the time on the left hand side, we have 5 plus 1, and here we have 25 minus 1, that's equal to 24, which is equal to 6 over 24, and by 6 it is 1, by 6 is 4. That's not equal to 1 over 10. So this cannot be the answer. If it is 7, 7 plus 1, it is 8, and over 7 times 7, 49 minus 1, it is 48, which is equal to 1 over 6. Again, 1 over 6 is not equal to 1 over 10. Also, that's not the answer. And how about if it is 9? 9 plus 1, it is 10. 9 times 9, 91. 9 minus 9 times 9, 81. 81 minus 1, that's equal to 80. And divide by 10, numerator and denominator, that is 1 over 8. Also, it doesn't work. And how about 11? When it is 11, here we have 12. And 11 times 11, 121, minus 1, it is 120. And if you divide numerator and denominator by 12, so here we have 1 over 10. On the right hand side, we have 1 over 10, so that is correct, right? So the right answer is 11. That's one way. So that's why Nigar, Elmira, especially these multiple choice questions, try to solve every question correctly, because the questions are easy. Okay, so if you get actually Sasmo stars, when you just start doing the question, you have 15 points. If you do this 15 questions correctly, that means 30, you will get at least 45. And if you get maybe 3-4 questions from the last part of the exam, you will get like 60, which means that you will get maybe silver, like at least. Okay, good. How about the next question? Which of the following cubes cannot be formed by folding the figure on the right? C, why C, Elmira?
Because 3 will be at the top of.
Say again.
And if so, like 3 will be on the top, then 1 will be on this side, 2, yeah, again 2, and 4, and 5, and then 8 again at the, how can I explain it? On another side. So 1 can't be on the top.
And also Nigar is saying that it is C. Leila,
Yes.
how about, what's your answer, Leila? Yeah, just join T.
Maybe still 2, yes.
Leila, say again. Do you have any idea? What's your answer?
Mr. Qasim, I changed my answer. It's E. A. A.
A or E?
A. A.
A. Which of the following cubes cannot be formed by folding the figure on the right? Okay, go. Let's do this one by one. For example, let's say A. Is it possible to make A or not? If yes, why? If not, why?
I think yes, it is possible. Mr. Qasim?
Are you sure?
No.
I think it's not possible.
No?
A is
Can.
not possible. Number one, it says which of the following cubes cannot be, right? Cannot be. A is not possible. You know why, Nigar? Look at this. Here, if I just take this one, all right, look at 5 and 6, right? But this one, as you see here, if I actually just take into rectangle, it's not possible, as you see here.
I understood.
Okay, so A is not possible, right? Okay, you agree with me. And how about B? If 3 is at the top, right? And the 3 and the 2, they are parallel, as you see here, they are parallel, right? They are parallel to each other. So here we have 3 and 2, they are parallel. And on the right, we have 5. So it is possible, right? And how about C, for example? 1 at the top, okay? 3 to the sides, and the 2. Again, 2 and 3, right? Yeah, it is possible also, right? C. Because here, 1 is at the top, 3 and 2, is see here they are parallel, here they are parallel, and 1 is here. So that's also possible. And how about D? What do you think about D? Nigar, Elmira, Leila. Is it possible or not, D?
It's possible. Because
I think
5
it is possible. I also think that it's possible.
to 5 and 4.
Yes.
Yes, it's possible.
Okay. Also, D is not possible, right? It's not possible. Because, Nigar, look, this 5, I'm just folding down. And look at the 3. How is this one? This one. 3, look at this 3, like this, and 4. You see?
Yes.
Or I can just take the rectangle like this. How about if I just take the rectangle into this, for example? Can I do like this? No, because actually, if this 3 were like this, for example, it would be possible, right?
Oh.
But here, if you look at the 3 and 4, if you are folding this 4, right? And this, our 3 is like this at the top. But here, this 3 at the top, it is in different direction, right? As see here, it is like this. But here in the picture, our 3 is like this, comparing to 4. So, and also D is not possible. Okay. So what is the answer? Our answer is A and D. But actually, there must be one answer. I don't know why they put this question like this. Anyway, let's move to the next question. Let's not waste much time on this. Nigar, did we saw a similar question before?
I think in geometry we did it, but
No, 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 not in geometry like this, exactly like this question. No, right? Okay.
well,
So, Nigar, can you read the question?
in the figure below, find the ratio of area of the shaded region to area of the unshaded region.
Okay. Here, find the ratio of the area of the shaded region to the area of the unshaded region. Okay, if the question is clear, girls, try. I give you 2 minutes. Okay, and to find the area, simply we have to count the shaded squares, right? How many squares are shaded, and also how many squares are unshaded. Or to find the number of squares which are unshaded, first altogether find how many squares do we have, and subtract the shaded regions. It gives us unshaded region, which is actually unshaded squares. Okay. You have exactly 2 minutes. Let's see if we get the correct answer. Time starts now. Elmira,
Yes.
in the question is asking find the ratio, right? Find the ratio of the area.
Okay. Sorry.
Nigar, Leila, how about you? Faster. Nigar, why is it taking so long?
1 second, I'm trying.
Leila, did you get anything?
Some minutes.
Oh, Nigar, Leila, so slow. Why so slow? Why? Just you need to count here, right? Is it S, for example, how many squares do we have? 11. So we have two S. I don't have to count the second one, 11. In A, first count the vertical, 5, 5, it is 10, 1, 1, it is 12. M, the vertical 1, 2, 3, 4, 5, multiplied by 2, it is 10, 11, 12. These two triangles, right? And altogether 14. How about O? On one side, 1, 2, 3, 4, 5, and 5, and 1, that's 12. That means that 12 squares are shaded. And what is the dimension of this rectangle? It is 25 by 8, which is equal to, it is 200. We have 200 squares here. So find the ratio of the area of the shaded region. So the shaded region over unshaded region. Unshaded region. And what is shaded region? It is 11, 11 plus 12 plus 11 plus 14 plus 12. And how about unshaded region? Altogether, we have 200 squares minus, and let me just write here. This one, actually, this together, if you just add this, they are all together, that's equal to 60. So 60 squares are shaded. If I just subtract from all gray shaded regions, right, shaded squares, and the remaining ones are unshaded squares. So here we have 60 over 200 minus 60, 140. 0, 0 cancel each other. Divide 6 by 2, it is 3. Divide 14 by 2, it is 7. So the ratio is 3 to 7. Elmira, why did you get 27 over 25? How is it possible? It says shaded
Now,
to unshaded.
let me explain. Like when you write 25 multiplied by 8, I think that it's unshaded region. Like I
Okay.
didn't know that it's all together.
Hmm.
So, so like that.
Yeah, because unshaded means which are not shaded, right? Which is not Sasmo. The Sasmo is shaded, and outside Sasmo, those squares are unshaded. Leila, did you understand? Okay. Elmira, if it is clear, let's move on to the next question. Uh, Elmira, read the question.
In a magic show, the magician placed four cards on the table as shown below. Each card has a mass symbol on one side and a number on the other side. After showing the cards, he flipped over saying maybe all of the cards and rearranged them. The new argument of the cards is shown below. How many of these four cards have an even number on one side?
Girls, you have 1 minute to answer this question. I think it's quite easy question, okay? 1 minute. Write your answer to the chat box. How many of these 4 cars have an even number on one side? How many even numbers? 1, 2, 3, 4. Because we have 4 cars, maximum 4, right? So your answer either should be either 1 or 2 or 3 or 4. Okay, I got the answer from Elmira, and that's correct answer, but you'll have to explain. Leila, Nigar, how about you? Leila, what's your answer?
Three, maybe.
What did you say?
Three.
What did you say?
Sent you my answer in chat box.
Okay. Elmira, can you explain quickly why did you get 3? Why is your answer 3?
Yes, when he flipped some of the cards, he flipped just only 3 of them because to like is it how can I explain? There are only 3 different numbers, so maybe he turned only 3 of them, and the last one it's 2. He just didn't flip it.
Good. As you see in the car section, we have front and back, right? We have 4 mathematical symbols and also 4 numbers. As you see here, 4 mathematical symbols, they are multiplication, subtraction, addition, and division, right? And the first one, multiplication and the subtraction, right? In the second one, we don't have these symbols, which means that at the back of multiplication, it must be 3 or 2. It doesn't matter. Let's say um, it is 3. And that means that behind this minus, it must be 2, right? So this one, we have already used this one. Behind this one, we have this 3 and 2. And how about this addition and the division? It must be then 8 and 2, right? So at the time, how many of these numbers are even? That is 2, 8, and 2. We have 3 even numbers. So how many of these 4 cards have an even number? Because it's not asking how many even numbers. They're asking how many of these 4 cards have an even number on one side. So the answer is, it is 3. Okay. Next question. Leila, read the question.
The bar chart below shows the number of cars sold in town A. In the first half of the year 2015, all the horizontal lines are equal space. The difference between the number of cars sold in the month with the high sales and the number of cars sold in the month with the low sales is 60. How many cars were sold in the first half of the year?
Okay, as you know, since actually started from 2016 in Sasmo, there is one question related to statistics. Okay, that is a statistics question. The bar chart, and we have different ways of representing data, right? Sometimes we can use bar chart or histogram or frequency table or line graph or semi-leaf diagram, and also you must be learning at school. Anyway, the bar chart below shows the number of cars sold in town A in the first half of year 2015. The first half is in the January, February, March, April, May, and June, right? All the horizontal lines are equal in space. The difference between the number of cars sold in month with the highest sales and the number of cars sold in the month with lowest sales is 60. Which one is the highest? Highest is June, right? And the lowest it is February, right? So the difference is it is 60. How many cars were sold in the first half of the year? Girls, you have 2 minutes and 15 seconds, okay? Try, it's very easy question. Leila, did you understand the question? Good. All right, time starts now. Let's see. Very easy question. Nigar, are you sure?
I think yes, if it is the first half of the year.
How did you solve it?
Because we see that in June, yes, we have 60 cars, and how can I explain it? We have
Nigar,
six.
look, Nigar, look. Here, just one thing. It says
Yes,
that the difference, right? The
yes.
difference, what is it? What is it? The difference, okay, the second sentence, right? The difference between the number of cars sold in month with the highest sales and the number of cars sold in the month with lowest sales is 60. The difference is 60. How can it be 10?
Oh,
How many cars were sold in the first half of the year in 6 months? Right? If it is difference is 60, it must be more than 60. Did you understand, Nika, what I mean?
yes, yes.
Elmira, how are you solving this question? Are you solving or thinking?
No, I am sewing.
Solving. Good. Leila, you?
Yes.
I'm sorry to.
Solving. How are you solving, Leila? Tell me.
I know one I can say the thing.
Louder, please. Louder. I cannot hear you well.
Oh, uh, I know one thing. I don't know what I can say. It is 60. In January, it is 120 in the other.
Oh, okay, Leila, Nikia, Elmira, if you're solving like this, it would be great. And suppose that the length of each actually, what is it? Horizontal lines, right? Between two horizontal lines. Let's say it is x. So in the first one, we have 2x. Second one, we have 1. Third one, 1, 2, 3, 4. Here we have 4x. And 1, 2, 3, 4, 5. Here we have 5x. This one is 6x. This one is 6, 7. This one is 8x. No, this one is 4. So less than 5, that's equal to 4x. And this one is 6x. So now it says in the question, the difference. Okay. So the difference, right, between June and February, that is 6x, the biggest one, and the shortest one is x. That's equal to 5x. So it says that that's equal to 60, right? So that's equal to 60. So from here, what is x? X equals 60 over 5. That's equal to 12. So now we need to find the total number of cars sold in the first half of the year. How many x's do we have here? 2 plus 1, 3 plus 4, 7 plus 5, 12 plus 4, 16 plus 6, that is 22x, right? And 22 times, what is the value of x? That's equal to 12. 10 times 22, that's 220. 2 times 22, that's 44. So that's equal to 264 cars. So in the first half of the year, altogether 264 cars were sold. Okay, Leila, Nigar, did you understand?
Yes.
Are you sure?
Yes.
Good. Let's move to the next question. At least now you have some idea, because soon we are going to solve similar question in the next paper. Let's move. These are just warm-up exercises. Nigar, read the question.
So when 70 is divided by x, it gives a remainder of 2. When 121 is divided by x, it gives a remainder of 2. What is the value?
Remainder.
Oh, remainder of 2. What is the value of x?
Also very easy question. Girls, you have 2 minutes, okay? Time starts now.
I send my answer to you, Mr. Gus.
Nigar, if you divide 121 by 4, what is the remainder?
Um,
Huh?
1 second, I will find it in my notebook.
121 is equal to 4 times 30 plus 1. Remainder is 1. But it says that when 121 is divided by x, it gives a remainder of 2. Banana. Yeah. You want to eat it? Do you like banana? Okay, take it. Leila, Elvira, any answer?
Yes, just a second. I want to solve it.
Okay.
Minute.
Elmira, got it? Shall we do it together? Do you have any answer?
No, we can solve it together.
Okay, look, just one. I'll show you one thing once again in division algorithm, right? For example, if you divide again, let me just write 17. I don't know. Every time this 17 comes to my mind. So here, if you divide it by 5, for example, here we have the quotient. It is 3. The remainder is 2, right? So the 17, I can write it as 5 times 3 plus 2. And actually in math, the 17 is a dividend. This is how we call this. 5 is dividing that number. That's why we call this divisor. And 3 is a quotient, right? And 2 is remainder. Every number, every whole number, if you divide it by another whole number, we can write this in this way. So now in the question,
Mr. Qasim, I find the answer.
what is it?
17.
Yeah, that's the correct answer. How did you get it?
I came to 16. I stopped there, but I think that let's do
So you divide one by
17
one?
too. Yes, yes.
Oh my God, that's not a good methods. How about if the answer was like 79, for example? You would try until 79?
I think now I can't.
Okay, no, that's not a good method. Okay, your method is right, but it's not the best method. So I'm going to show you the best method. How can we do this any question? Okay, like this in the shortest way. So now by this rule, if you divide 70 by x, right, by x, here we have some quotient. Okay, quotient. Let me just denote this by q1. And what is the remainder? Remainder is 2. And it's saying that 121 is divided. This 121 is divided by, again, x. And we have another quotient here. Again, the remainder is 2. Okay. So now if I subtract side by side, what happens here? 121 minus 70, that's equal to 51. And 2 minus 2, that's equal to 0. And here we have x times, here we have x q2 minus x q1, right? What is x? X is a common factor. I can take this out. So I can write it as x times q2 minus q1, right? So which means that we know that this 51, the only way that I can write it as 3 times 17 or 17 times 3. So which means that here x is equal to 3 or x is equal to 17. We don't have any other possibility here because x is a whole number. Q2, Q1 is a whole number and x is not equal to 1. So as it's here, if you check for x, for example, it does not work because if you divide 121 by 3, the remainder is 1. So it does not the answer. But if you divide it by 17, it works for both of them. So the answer is here, it is 17. Okay, Almira.
Okay.
Maybe actually, I don't know, maybe it's a little bit you understand, maybe you understand everything. Usually that is called a division algorithm. We use this method to solve this kind of questions. Otherwise, Elmira, your method, guess and trial method, you will waste a lot of time. So let's continue. Girls, there's something wrong with this question. I will skip it for now, okay, until I correct this. So let's actually do this question. Nigar, can you read the question?
Yes, the figure below is a rectilinear shape. Shape. What is the perimeter of the figure below?
Okay, we did a lot of similar examples. All right, you have 2 minutes. Leila, are you sure? Leila, your answer is so close, but it's not the correct answer. Can you have a look? Elmira, did you get anything?
Yes, I'm solving.
Solving still, Nigar?
I have one answer, but I'm not sure in it.
Tell me your answer. What did you get?
180, but also I'm not sure why I did it.
180 is a lot, Nigar. It's a lot. How come?
Oh, period. Oh, 1 second.
Girls, you should be able to solve this question correctly.
Oh, I'm sorry. I'm sorry. Is it closely with 56?
No,
No.
no. Answer is greater than 70. Leila, now you got the correct answer. Did you see your mistake?
Yes, I have a mistake on my when like I said
Okay,
last time.
good, good. Elmira, you still calculating? Why it's taking so long, Elmira, Nigar? Look,
So
we need to
now,
find the perimeter, right? Let's just start from here. Now, if you look at the top, for example, we know that the sum of the length of the parallel lines, right? It is equal to 18. If you look at this, for example, let's say this plus this plus this plus this plus this plus this, that's equal to 18. So the perimeter is equal to bottom, it is 18, right? And also top, it is 18. Okay. Now I have calculated all the horizontal lines. So now we will calculate vertical lines. Plus, and here we have 10, right? It is 10 plus, here we have 4 and 2, that is 4 plus 2. And here we have 4 and 6, it is 4 and 6, right? And here we have 8. Okay, 8. But if you notice here, okay, 4, 2, and also this side is also 4, right? I should add 4 one more time. And also this side is 6, I need to add 6 one more time. So that's it. 18, 18, 36, and 10 for this one, it is 16, and this is 10, and the okay, 10, and this one is what is it? 12, 18, right? So which is equal to, this one is 52, and this one is 70, that's equal to 80. So in this kind of, the best way is first find the total length of vertical lines, and after that horizontal lines. As see here, top and bottom, right? All the sum of the all horizontal lines, that's equal to 18. Elmira, any questions?
no, at the end, not at the end. When I say that I'm solving, I find this way, and I've been
Did you
solving.
get 80?
Yes.
Good. Okay. All right. Let's move to the next question. Elmira, read the question.
6 machines can produce 150 parts every 30 minutes. However, the manager discovered 10 defective parts every 40 minutes from each machine. How many additional machines are needed to produce 1050 functional parts every hour?
6 machines can produce 150 parts every 3 minutes. However, the manager discovered 10 defective parts every 40 minutes from each machine, right? From each machine. So how many additional machines are needed to produce 1050 functional parts every hour? Just give a try first a little bit, okay? Then after that we will solve together. You have 2.5 minutes. Elmira, Leila, Nigar, do you understand the question or? Okay, girls, let's do it together. Okay, we are running out of time. So that is actually, what is it? It's a rate problem in math because we are talking about machines and parts and blah, blah, blah. Okay, so now let me just make a table here. Okay, now we have one answer. Elmira says 64. No, Elmira, it's not 64. So here, let me just write here. The first one, we have machines, okay, and the minutes, and the, what is it? Total parts. Because now, first, we don't know, right? And the second one, I just write here, okay, maybe machines, okay, and here we have minutes, and here we have defective parts. First, it says in the first part, 6 machines can produce 150 parts every 30 minutes, right? And here, if we have 6 machines here in 30 minutes, right, they can produce 150 parts. So here it says that how many additional machines are needed to produce 1050 function parts every hour. So now let's just see, in 1 hour, one machine is producing how many? Because I need to find, okay, if they are asking functional parts, right? In 1 hour, how many actually, how many machines can produce how many functional parts in 1 hour? First, we have to find this. So now from here, we know that if we have more machines, we can produce more parts, right? So that means that they are directly proportional to each other. That means that if I have less machine, let's say if I have only one machine in 30 minutes, right? How many total parts they can produce? 150 over 6, that's equal to 25, right? Because every machine is producing 25. If 6 machines are working together, in 30 minutes, they can produce 25. Now, how about one machine if it works 60 minutes, right? 60 minutes, 1 hour. 30 more minutes, they can produce 25 more machine parts. So actually, they can produce 50 parts total. Now, in the second part of the question, it says that, however, the manager discovered 10 defective parts every 40 minutes from each machine. So that means that from each machine is from one machine every 40 minutes, right? How many defective parts? 10 defective parts are coming. So again, now we have to find this one machine in 1 hour, how many, right? So we know that actually 40 minutes in 10, that means that if it works only 20 minutes, it will produce only 5 defective parts. So now, how about, actually, I'm not changing the number of machines here. One machine works 60 minutes, right? That means I multiply this by 3, it is 60. And also I need to multiply by 3, it is 15. So now if you look, compare this one, in 1 hour, right? I mean, 1 hour, one machine producing 50 parts. So in 1 hour, right? Actually, one machine, 15 of them are defective. So now in 1 hour, how many? Let me just write here, machine now, machine, okay, minutes, okay. Here we have functional parts, right? So one machine producing in 60 minutes, how many functional parts? 50 minus 15, which is equal to 35. So the question is, actually, we know that 1050 is divided by 35. That is equal to, is it 30? Yeah, is equal to 30, right? Because 3 times 35, it is 105. So if we multiply this by 30 in 1 hour, actually, if we have 30 machines, each machine is producing 35. So they will produce how many? 1050. Okay, so that means that if 30 machines work for 60 minutes, that is 1 hour, they can produce 1050 functional parts. But in the question, again, that's the tricky question. It says that how many additional machines, right? And initially we had, at the beginning, we had 6 machines. So to find the number of additional machines, dot, 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 we need 30 minus 6. So the answer is 24. So we need 24 machines to produce 1050 spare parts in 1 hour. Okay. Because another question is interesting question. You can try at home, okay, and later we can discuss the solution. And 24 and 25, they are a bit long questions. In question 23, some triangles can be formed by connecting 3 points as the vertices in the diagram. How many triangles can be formed in total? You have to find this. Like, for example, I can form one like this, right? And also I can form another one like this, right? Or I can form this one again, for example. We can form a lot, okay? What do you think? How many triangles we can form using these dots? That's a bit challenging question. Okay, Elmira, Leila, Nigar, let me finish the class. And next time we will solve 2017. I think I already shared the paper with you. I will check this. If not, I will share with you. Because if possible, practice the questions. If you are too busy, at least have a look. Okay, have a look at the questions. What kind of question we are going to solve. So before you come to the class, if you come with some idea, we can go much faster. Okay, we have only 4 hours left. My 1 hour is gone. We have only 3 hours. Okay, try your best, and after that, you're going to have a long holiday. Okay, Elmira, Leila, Nigar, do you have any questions?
No.
Okay, girls, have a good night. I have another class now. Okay, I will see you on Thursday. Okay.
Thank you. Bye bye.
Okay, bye bye. Thank
Thank
you.
you, Kevin. Bye.
Bye bye. Thank you.